Finally, we come to Newton's third law. Now, Newton's third law states when a body exerts a force on a second body, that second body exerts a force on the first that's equal in magnitude and opposite in direction. You might have heard the law stated, for every action, there's an equal and opposite reaction. So it just means that the forces are paired. Whenever object 1 puts a force on object 2 puts an equal magnitude and opposite direction force on object 1. For example, the force on you by the Earth is balanced, or not really balanced, but is equal and opposite to the force on the Earth by you. Sorry, I used the word balance. You can see there's an obvious misconception. These forces don't cancel one another out. Even though they're equal in magnitude and opposite in direction, they are applied to different objects. One is applied to you, the other is applied to the Earth. What that simply means is, think about how hard the Earth pulls on you, right? When you jump up and land, you can feel how hard the Earth pulls on you. But you pull just as hard on the Earth. When a bug splatters on your windshield as you're driving on the highway at a high speed, the force on the bug from your windshield equals the force on your windshield from the bug. Or if you're on roller skates and you push a friend that's on roller skates, the force from you applied to your friend, right, on your friend from you, is equal in magnitude and opposite direction from the force on you from your friend. Every force is paired this way. There is no single force that exists outside of this rule. If one object places a force on a second object, that second object pushes back. That is how it works. Now again, these forces don't cancel, so the net force on an object is not zero because these forces are on different objects. When you calculate the net force, you're calculating the net force on that object, not the forces by that object. And that's an important critical point I have highlighted here. An object's motion is determined by the forces on that object from external sources, not the forces by that object on external forces. So for instance, the moon's orbit around the Earth depends on the Earth's pull affecting the moon, right? The force on the moon from the Earth affects the moon's orbit. The force on the Earth from the moon affects the Earth's orbit. The forces on the object determine the object's motion, not the forces by the object. This is an important and critical distinction to be able to understand. When I go and push a box, that box pushes back on me. However, the box's motion is determined by the forces on the box, not the box's pushback onto me. My motion is determined by that force.